Welcome to the Sixplaner. Today, we're looking at JavaScript, which is kind of like an incredibly eager but sometimes deeply confused assistant when it comes to math. I mean, it really wants to help you out, but sometimes it just doesn't know how to handle what you're asking it to do. And, as beginner developers, understanding exactly how this assistant thinks is absolutely crucial to writing great code. Okay, let's dive into this. We've got a clear 4-step roadmap today. Section 1, JavaScript's helpful math quirks. Section 2, discovering not a number. Section 3, validating with isNaN. And finally, Section 4, the double negative check. Section 1, JavaScript's helpful math quirks. And this brilliantly illustrates exactly how JavaScript tries to be overly helpful when mixing different types of data together. For example, if you add the text string 5 to the number 10, JavaScript doesn't actually do the math. It just concatenates them. It squashes the text and the number together to give you a brand new string that reads 510. But if you use multiplication, 5 times 10, JavaScript basically says, wait a minute, there's a number inside that text. It forces the string into a number and actually does the math, returning 50. It's just JavaScript trying to be helpful and guess the result you probably wanted. Section 2, discovering not a number. So this brings us to a logical breaking point where our helpful assistant can no longer guess what we want. Can you multiply apple by 5? Seriously, think about it for a second. You might end up with 5 physical apples in the real world, sure, but mathematically speaking, multiplying a word by a number is completely absurd. The code literally cannot multiply text. So what happens to our overly helpful JavaScript assistant now? Well, it gives us this, NaN. NaN stands for not a number. It's a property representing a value that is not a valid number resulting from a mathematical operation. And what's fantastic here for us as entry-level developers is that JavaScript doesn't just crash your entire program when it hits this absurdity. Instead, it returns NaN, which is essentially the engine's way of telling you, look, whatever you just tried to do simply does not make sense. Go back and fix your code. Section 3, validating with isNaN. Let's translate this into a real-world scenario you will definitely face, a website user entering bad text data into a form. Imagine you have an app that calculates the meaning of life using a highly complex mathematical formula. Let's walk through this disaster scenario step by step. Step 1, you ask the user for their age in a form field, expecting a number, right? But they decide to type in the word apple. Step 2, your code blindly takes that word and runs it straight through your mathematical formula. Step 3, the result is entirely ruined. Your formula tries to multiply or divide by apple, resulting in NaN, and your application completely fails to deliver the meaning of life. This highlights exactly why beginner developers absolutely must validate data before running mathematical formulas. We have to check the data first. Now, what's really interesting about this slide is how we can solve this using a built-in JavaScript function called isNaN. Think of isNaN as a tough nightclub bouncer who stops words from entering a numbers-only VIP area. The bouncer logic has 3 simple steps. Number 1, the bouncer asks the data, is it NaN? Is this not a number? Number 2, if the answer is true, like when the user entered apple, the bouncer says, that ain't even a number, and kicks them right out. Number 3, if the answer is false, meaning it actually is a number, the bouncer lets them in to run the meaning of life formula. It's a perfect gatekeeper for your code. Section 4, the double negative check. Okay, we're now going to look at a slightly advanced coding move that essentially reverses our bouncer's logic. It's a fantastic trick to have in your developer toolkit. Focus entirely on this single character, the exclamation mark. In JavaScript, the exclamation mark is the not sign. It's the negator operator. When you pop this symbol in front of a statement, it creates a powerful double negative, flipping the logic entirely. So, the crucial point is how this negator operator combines with our isNaN function. If we write exclamation mark isNaN, we are literally saying in code, is this not a number? Not true? It gets a little confusing at first, kind of like a tongue twister, but it translates perfectly in conversational logic to verify that the input actually is a valid number. It reverses the not a number check. If the word apple makes isNaN evaluate to true, then adding the exclamation mark makes it false. We've effectively created a check that says, only run this code if the value is indeed a real number. Let's bring all of this together and recap the core takeaways from this explainer so you feel fully empowered to use these tools to make your code more resilient. Number 1, NaN stands for not a number. Number 2, it's triggered by invalid mathematical operations, like trying to multiply text by a number. Number 3, we can catch these errors early by checking data with the isNaN function. And number 4, we can use the negator operator to create !isNaN to specifically confirm that a value is a number before we let our code proceed. So what other JavaScript quirks can you tame using simple logic? JavaScript is full of fascinating little oddities exactly like this one. But as you've seen today, they aren't roadblocks at all. They're just puzzles waiting for simple, logical solutions. Keep exploring, keep questioning, and keep coding.